Hello, and welcome back to my channel, or welcome to my channel. My name is Jack Blade, and welcome to the classroom. Today, we're starting a little bit of a video series where we talk about logistics specifically. And these are going to be long videos, so get drinks, snacks, and be prepared to take notes. There will be a test at the end of the last one. And on top of that, this entire thing will be available to you guys on my Google Drive. We'll talk about that later. Let's get into everything that you need to play Logistics, the game. Both Professor Bean and I agree that this first video is a must-watch for everyone, no matter experience and skill. Chapters will help navigate, and there will be like a playlist with all the videos in them and stuff like that. And I would put a in parentheses N for parts that are specifically for new players, like so. And this is the one-stop shop for everything that you will need to know about logistics. And it will detail a methodology, my methodology. And I have created this over the past like 4 years while I've been playing and having fun in the game. And I deviate from it a lot, but that's because I want to challenge myself. It gets boring otherwise. What I want to talk to you about is why I'm qualified to do this. First of all, I have almost 1900 hours in Satisfactory. I also worked for many years as a forklift driver and a warehouse manager, and I've been working as transport logistics. I've been working with deliveries. I've been working with like in factories. I've been working pretty much everywhere where you can imagine logistics and automation, transport, storage management, like whatever you want to call it. And it has given me insight into how to use it in real life, which makes it easy to transfer into game. And on top of that, I am a card-carrying member of Team Have Finished the Game. So, what you guys need to understand is, thank you, first of all, damn it, Carl, for gifting me the mug. I have the mug and everything to prove it. I finished the game back in update 7, and I have been messing around in the game all the way since way back when. And I really, really hope that I can help people fix and upgrade their thinking about logistics and ultimately make the game more enjoyable. That is the goal. These videos are for Satisfactory, but will work for any game that has logistics mechanics. Even like processes in real life, you can probably apply a lot of this. Just adapt for the game's specific mechanics and you're gonna be fine. These longer videos also take a lot of effort, but can really hurt in the YouTube algorithm. You guys can help by liking, commenting, and above all, share with family, extended family, friends, and you know that grumpy neighbor down the street who really needs some Satisfactory in their life. Like you look at them, you can just tell they haven't put down enough conveyor belts yet. Like that person, you know exactly who I'm talking about. That will do so much for the channel and help me a bunch. I also have a few disclaimers before we really get into the weeds of everything. This video will detail a methodology, or these videos. If you want to play the game in a way that you enjoy, and this is not it, if chaos is fun to you, that's how you should play. I am not trying to tell people how to play, but for the rest of these videos, I will speak with the assumption that this is how you want to play, and that you are following along and trying to follow these instructions. So just so you know. Also, I've been very clear and detailed in documenting my methodology, and the videos will really make it out as a lot more complex and difficult than what it really is. This is due to the nature of the high level of detail. Once you've done this on a very small scale once or twice, it becomes incredibly simple and intuitive. If you are a new player, or if it is the first time you apply a system like this, start very, very, very small. Don't do this for the first time with your nuclear power setup or your heavy modular frames. Like, that's gonna destroy you. Make sure you follow along step by step to not get overwhelmed. Skipping steps will have knock-on consequences down the road. Also, all the blueprints shown in the video or in the videos will be available for free on my Google Drive. You can find it by joining the Discord and going to the Google Drive chat to find the link. There's going to be save files, blueprints, mods, stuff like that, because I'm using mods to set this save up. The classroom is a creative world, and these mods help you place down resource nodes, build a lot of like foundations and walls and stuff really quickly, nudge with incredible detail, like all of it. So these mods is meant to create a sterile environment to do testing and stuff in, where you don't have to involve the game map. That's something that you need to keep in mind as well. If you are looking for specific parts, use the chapters in the description to navigate, and as I said before, I will mention when I'm going over very basic mechanics, so the advanced players can skip that part. For now, we will start by going into the table of contents for the videos, for all of them. This is my second attempt at recording the entire like video series kind of thing, because I was not happy with how I did the first time, so I'm doing it all over again. And what we're looking at in terms of table of contents, every single video will have like an intro, outro, all that kind of stuff, but outside of that, we're going to go over a little bit of terminology in this video. You will also find all of the terminology, like specific language that I use or that is common for Satisfactory that new players might need help with. It's going to be in the description, and I will mention when that's relevant. On top of that, we'll go through the logistics hierarchy. Once again, that terminology is available in the description, but I will also explain it because there are like sub-headers to that I won't fit in the description. We're gonna go through logistics layers for the same reason. And we're gonna go and talk a little bit about how I come up with all of this, because I kind of want to make sure that you guys know how I come up with it and where it is from, and I also want to give credit where credit is due, because I was inspired by another YouTuber, and we're gonna be talking a little bit about that, and I want to shout them out and show some stuff. So we will be doing that in this video. For the next video, we're gonna be doing the actual planning, step 1 and 2. So if you have like watched a lot of my videos before, you've probably seen some version of me talking about these things. And then you can probably, like, I recommend still watching the entire video, but these are the places where I actually start planning factory and planning logistics. The second video is the actual factory planning. And then we will be going over in step 1, we'll be going over junctions, main lines and highways. And in step 2, we'll be going over production lines, local lines and collectors. And then in the third video, which is themed if you don't have time to do it twice, do it right the first time, which is a life lesson my dad gave me. He's been working in logistics and transport and stuff most of his life, which is probably why I have a natural inclination for it. Here we're gonna have step 3 is visualize and simulate. Before you build anything, do an extra step over and actually visualize and make sure that everything looks correct. If something feels off, it feels wrong, you can fix it because you have done this before you spend hours and hours building stuff. Prepare blueprints is step 4, which is actually spending a lot of time over there building a lot of the blueprints we need for the factory. And then we will be going over into video number 4. And that is the fruits of your labor. This is where we do the final step of planning, which is preparing the spaces, actually having the spaces planned out and laid down so that we can build. And then we will have the building order of operations, because if you build this in the wrong order, you're gonna have a real bad time, especially for larger factories. And then I have a little bit of a conclusion thing where I kind of want to talk about like some ending notes and thoughts on this methodology and how it can apply to other people and stuff like that. And that is these videos in their totality. And hopefully you guys will have a really good time. So if you've watched this video before and you're like, yeah, I don't need this again, but I do need help with like, okay, which blueprints was it I needed? Just skip to video number 3 and go to the chapters in that video, and you will be able to find what you need in terms of blueprint stuff. That's essentially how this is going to work. Now, we want to get into actually doing this video. Sorry, one final note before we really get into it. If you're a content creator watching these videos, I do highly encourage you to reference, react to, spin off, review, or straight up copy the method for your world, for your videos, for whatever. All I ask is that you mention like my channel and link the playlist for the series in the description for where you apply it. Or if you just want to do reactions to it or whatever. All I ask, and the same thing, like the same courtesy that I extend to everyone else, is just the credit where credit is due. That's all I'm asking. Now, let's get into the actual meat and potatoes of the video. The important terminology that is probably new to everyone that I want to bring up is the concept of faucets and sinks. Faucets is a system that inputs resources into the game, like mining nodes, spawning mobs, and generating power. Sinks is a system that deletes or eats up or compresses resources to reduce space usage or entirely remove them from the game. Awesome sinks, power usage, and advanced low quantity end product production are examples. And then I also want to bring up, when I'm talking about, translation. Translation is communications between different logistic systems. So we're talking about mechanical translation specifically. And then on top of that, I would like to mention logistic systems is its own thing versus logistic layer versus production line versus everything else. So make sure that you take an extra look at the terminology stuff in the description to feel like you have a somewhat grasp of how I talk about things. And that's really, really important because I won't be bringing it up again. I will basically just assume that you know what these mean because I've put the definitions in the description. Now, we are going to be looking at logistical hierarchies. A logistics hierarchy is a method of planning, sorting, and thinking about logistics system construction. So, this is what we will be looking at. The first one we will be looking at is the junctions. And junctions is where buffering, splitting, merging, balancing, and translation between layers and a hierarchy happens. This needs a lot of space to not feel cramped and have space for balancing and transfers and those translations for them to take space. If you are thinking about only belts, you're making a mistake, because when you're looking at anything in the logistics hierarchy, it can be anything. It can be belts, pipes, vehicles, power nodes, priority switches, train stations, rail lines, like trucks and tractor paths. It can be literally anything that requires, like I said before, buffering, splitting, merging, balancing, and translation between layers and a hierarchy. And this is the place where you plan for the overlap of all your logistical layers. And you try to center these because it makes it a lot easier to have space and make the factory feel organized. Then we're looking at local lines. A local line is logistics feeding production lines or merging outputs, feeding storage or sink system. They are slow or low quality capacity for shorter distances. Don't try to be doing this across the entire factory. Few or single belts moving resources inside the factory away from the main lines. Feeding machines rarely needs advanced belts, pipes, or high quantity vehicles. The reason for this is there's only a few that actually needs like high capacity belts, such as the bauxite processing for aluminium production and stuff like that. Most of everything else, you are going to be fine with having like a Mark III belt or something like that to feed stuff. They are fine being very, very low speed most of the time. You just have to adapt it to what the numbers are that you need to move on your local lines. Local lines connects to either collector lines or main lines, never to resource highways. This is super, super important. When they connect to main lines, they connect to a junction first. So that's where you translate into the main line. Then we're looking at collector lines. They're moving things across other hierarchies outside of the junctions. So they are intended for any quantities. The purpose of them is to make translation between hierarchies faster and more efficient. Then, like I said, they apply and extend outside of the junctions. So, for example, if you have a main line, junction here, there's a junction here, you can take a collector and connect that up outside of that junction to feed a main line, or to move things away from a main line, for example. And this guys include connecting main lines and local lines, or it can connect a main line with a resource highway. They are very, very versatile, and that's the purpose. It's the only one of these that are that versatile. Everything else is extremely rigid. And the purpose of that is for the organization. The collector lines can then have the risk of becoming very messy unless you're careful. So keep that in mind. And we're going to show some example of that in later videos, how that actually is used or how that is applied so that it doesn't become messy. They are especially useful in mega factories and large modular factories with multiple intersectional production lines and multiple parts as a final product. We're gone on to main lines. They move resources between different production lines, storage, and junctions. Medium to high quantity capacities for fast transfer speeds. The main resource transfer method inside factories. And always starts and ends in a junction. The only way you move things out otherwise is by adding on a collector. Always plan for the largest possible main line in terms of space usage, where you can then contract or expand on that dedicated space as it flows along, using the collectors. Resource highways moves resources between faucets and factories and in between different factories. Is always planned for maximum speed and quantities. I also sometimes call these world highways or inter-factory logistics. It works absolutely best using trains and should be planned for Mark 6 belts and lifts and Mark 2 pipes. Like always, the maximum quantity, capacity, and speed. And I want to be clear for those who loves drones. Drones are best used as collectors. Don't look at drones for the main like resource highways or main lines or anything like that. Drones are good for collector. That's it. You can feed your resource highway with it, and you can move them away from the resource highway to factories, whatever. But the resource highway should be the fastest, highest capacity, highest quantity, whatever you have. We are now done with logistics hierarchies, and we'll be looking at logistics layers. And the way that I've defined this is as different methods of resource transfer that needs mechanical translation to interact. That is a lot of words that means nothing unless you have some context, and that's what we're going to be adding in. We're going to start looking at belts and lifts, outlines the space and direction of all other layers. So the belts are kind of the framework for where you connect up trains, pipes, whatever it is. Unless you have something that only uses one of the other layers, this is what you essentially look at. And the Mark 1 takes 60 resources per minute, Mark 2 takes 120, Mark 3 takes 270, Mark 4 takes 480, Mark 5 takes 780, and Mark 6 takes 1200 resources per minute. And you can see the resources here that they use to be built. Specifically for newer players, this is a really good thing to have in mind. And prioritize this production every time you level up your space elevator phases so that you immediately get the fastest possible belt. Now, which belt is good for what? Mark 1 should only be used as a local after you've unlocked your Mark 2 belts. Like they have no business being used any other place unless you have have only Mark 1 belts. So Mark 2 should always be used for other stuff once it's unlocked, local only otherwise. Mark 2 should be used as local and collector, and they are the main belts for phase 1. Mark 3 is the local and collector, and they're also the main and highway for phase 2. For phase 3, you're looking at the Mark 4 belt, collector and mainline, and the highway for phase 3. Mark 5 is the phase 4 collector and main, and then also the highway for phase 4. Mark 6 is the endgame mainline and resource highway, and basically it's very rare that you would then need Mark 6 everywhere else too, depending on how you've set up your production lines, of course. There's another thing that connects in with all of this though, and that is all of our storages. We have a variety of different storages in the game, and they do different things and have different strengths and weaknesses. So we have the storage container that has 24 slots, and then the industrial storage container, which has 48, twice that. So it's basically, if you think Minecraft, single chest, double chest, easy as pie. Then you have a dimensional depot uploader, which can upload things into your dimensional depot over here, which is remote storage. So I could take something, I can take these, put in here, and they're going to be uploaded into my dimensional depot no matter where I am in the world, and I can take them from there and pull out into my inventory and use. Or I can build and it will directly draw from here. So keep that in mind, that you do have remote storages and stuff, and you unlock those in the MAM. And then you have a example of a setup here where you can have like a storage that buffers things and then also feeds the dimensional depot uploader. So there could be a factory connected to this. And then you have liquid storages. These are complex and stuff. We're gonna go through those later in later videos as well, but essentially 400 cubic meters of storage space, and they work as a big pipe, so they don't have any mechanical differences to a pipe. They just have a lot more capacity to store things. So be careful that you don't cause backflow. And here is a larger version of that. Same thing there, single chest, double chest. And the main difference here is that this one takes 6 times more, so 2,400 cubic meters. And they're going to have the flow rate capacity that is based on the belts pipes connected into it. And then we have power storage. We have battery. So each of these can store 100 megawatt hours. If you don't know exactly how megawatt hours works, I recommend you Google it, or otherwise wait for later videos and I will explain how they work there. Then we have the sink and awesome shop. These doesn't really fit into anywhere else. I put them in here, where we're talking about the fix-it sink, where you can literally connect in a belt and any solid except for like these. You can't sync these things, like the summer sloop, power shard, or the Mercer sphere. You also can't sync power slugs, the snails that you can find around the world that has like the blue, purple, and yellow slugs. You can flush them in the toilet in the hub, but you can't actually sink them into the sink. So keep that in mind. These are all of everything, and the reason why I put it here is because you technically have this as a storage overflow protection, which is really important if you want to have continuously running factories at 100% efficiency. So a lot of the translation between different hierarchies can happen due to these. This is a merger, where you can take up to 3 belts and merge onto a single belt, and splitters, where you can take 1 belt and split in up to 3 different belts. And this is an even split, where you essentially get, if you have 300 here, you're gonna get 100 on this belt, 100 here, and 100 here. If you have fast enough belts going, of course. You have upgraded versions of the splitter as well, where you have the smart splitter, where you can set specific outputs to a specific item on one end. Like you can set that anything that isn't defined can go forwards, and you can set, like, if nothing can go either of these directions, you can set them to go to the overflow direction. So you can set these easily in here. And then you have the programmable splitter, where you essentially have the ability to add the same conditions, but a lot of them for each output. So it's essentially like no interface. You can set one thing per output, and you can set many things per output. That's essentially it. And you use these to load balance, to create priority systems, to... Yeah, there's a bunch of different things that you can do with these, and we will go through a lot of them in the future videos. But for now, all you need to know is that we have the mergers, we have the splitters, smart splitters, and programmable splitters. And then we have our pipes. The Mark 1 pipe can run 300 cubic meters per minute through them. And they are multi-directional, so you have to be careful and make sure that your pipes are saturated so you don't have sloshing and backflow and stuff like that in your pipes. And the Mark II pipes can move 600 cubic meters. Main difference here in terms of the logistical hierarchies is the Mark 1 pipes, once you have both of them, of course, the Mark 1 pipes is the local and collector pipes. Meanwhile, the Mark II pipes is the mainline and resource highway for your liquids. And what we can connect to our pipes are the pumps for head lift, because liquids needs help getting up when you're going vertically. And you have the Mark 1 that can pump 20 meters up, and Mark II that can move 50 meters up. This one drains 4 megawatts, this one drains 8 megawatts. And outside of the Hypertubes, this is the only logistical element that is like pipes, Hypertubes, belts, all that kind of stuff that actually uses power. Nothing else does. We also have the Junctions that works as a splitter plus merger for the pipes. And we have the valve, which can control flow amount. So you can set your number in here, and then you can set the flow direction. You see it has a little bit of an arrow here. If something comes in here and goes out there, it cannot pass back through it. So it's a great way of defending against overflow or backflow and sloshing and stuff in the pipes. However, that's only if you use them correctly. And there's a little bit of a glitch in the game that I'm going to be showing you. So if I mark these for dismantling, you can see that there is no pipe in the middle. But if I do the same thing over here, there's a pipe there in the middle. What's the difference? I actually placed in this pipe after I placed the junction. In this case, I had a pipe that I placed the junction on. And this is the case for all of these. Like, it's the same thing for all of them. When you have this, what happens is the game thinks that you have both a connected single pipe and a pipe with a junction at the same time. This doesn't always happen, but when it does, it starts jittering back and forth between those two, and they can cause a couple of percentages off of like blockage of the flow rate, and 2-3 percentages of hundreds of cubic meters per minute can be significant when you're trying to run something at 100% efficiency, especially when you have to run it at 100% efficiency. So the way you solve that is by doing this. You place in the junction first and then connect the pipe. Or if you place in something on an existing pipe, like so, you go in and you remove the pipe and you replace it afterwards. This is really necessary sometimes, especially when you're working with like pipes that have a little bit of a slope, for example. If you want to place something on a slope, you're gonna need to do this here to make sure that it actually works. Otherwise, you're going to risk having that problem. This solves, I kid you not, about 90% of all problems with flow rate. And then on top of that, if you want to solve the last 5%, then all you gotta do is make sure that you put your pumps before you start going up, and you go up and then down into your machines. Don't go up into your machines, go down into your machines, because flow, like the liquids, flow to the bottom first. That way your machines are prioritized to be fed. Now, this is super important, and I bet you will run into some problems. If that's the case, head on over to Discord. We help people constantly with their liquid problems there. and we are getting really good at it. Belts, pipes, and all of that has a max distance of 7 foundations. You can't make a belt or a pipe longer than 7 foundations. Same thing with lifts. They can only go to 13 high. So you would essentially place it so that you can build on the 12th if you want to just use one lift. However, you can also do this. And the way that this works, you can make an infinite height lift very, very simply by placing in a floor hole that you can get in the Awesome shop for the awesome sink coupons that you get from sinking a bunch of material. And then you can just make sure that you're straight underneath, and when you hit that conveyor hole up here, it will snap, boom, all the way up, like so. And suddenly you will have a lift. In this case, that is 100 foundation, as in 400 meters high, which is really, really good if you don't want to have to do the interlocking lift like this. This is the only other way to achieve the same result, by going up and up and up and up and up like this. So this way is a lot cleaner. This is my recommendation. It also uses less of these, which makes it less performance drain, puts less of a drain on your computer. Those are the max distances for that. Now we have other stuff we need to talk about, specifically all the vehicles, which is the next logistic layer. And we're going to start with tractors. Tractors are the smallest and the first thing you unlock. It can go up to 50 kilometers an hour and has low quantity and should only be used in local lines and locally. And this is specifically because it is so slow and can carry so little. You use them by setting up truck stations and connecting in with those. They have 2 outputs, 2 inputs, and 1 fuel input. And they take, let's see, what does it say here? 20 megawatts per station. The bigger version of this that you unlock later has 48 slots and can run at 75 kilometers per hour. They are what I would consider local and for medium capacity, for medium quantity transfers. For example, feeding trains with like mining node resources and stuff like that. Essentially collecting all the resources, put them on a train, and then run them on the resource highway. And then we need to move on from here. I'm going to just say, if you unlock the Explorer, it has a tiny inventory. It drains a lot of fuel, and it is unstable as crap when the autopilot is driving it. So don't use this for any logistics. I'm just warning you. You're not going to have a good time. Or you're going to have a good time if you're trying to make like a chaotic as crap world. Now we have trains to talk about. Trains have a bunch of different buildables, and you can have a bunch of different kinds of setups. But they are the most versatile of all of your logistics, and they can do a bunch of different things. So what can you make with the trains? You can build the station, which is the core of your rail networks. And then you have different kinds of platforms, where you have the freight platforms that handles physical items, like solid items, and then you have fluid freight that handles liquid items. And then you can also put in empty platforms for like filling out decoration or whatever other need you might have. And remember, these stations, when you start like loading and unloading with a train, they stop sending items in and out. So what you need in front of and behind, like in or out, no, it doesn't matter, you need to have buffers that like this, so that you have items here, so that while this stops sending stuff out, the container can still feed your production lines so you don't have stoppages. And you can control your timetables and everything from in here and see all your stations and make sure that you don't miss anything. On top of that, you have the electric locomotive, and then you can attach freight cars to this. The recommendation for like convenience is around 4 cars. You can run with more. You might start getting some problems. They might slow down too much. They might cause blockages. There might be some problems or crashes or whatever it is. Not computer crashes, train crashes. Then on top of that, we have our signals We have the block signals and we have the path signals that are used to control and prevent train crashes. So if there's a junction and you have 3 trains coming in at the same time, the one that gets there first will go through, the other 2 will pause and wait until it's gone through, and then they will continue. Unless you, of course, like made them go like head to head, in case they will deadlock and not move at all. And all of this, I made videos on this galore. If you want to learn more about that, just check out my tips and tricks playlist. There will be everything about railways, trains, signals, how to build junctions, slopes, set up networks, all of it. It's gonna be there. And something to keep in mind here, the maximum length that you can place a railway is 12 foundations. Technically 12 and what is like 12 and a third, 12 and something like that. You can build like out to here on this foundation. Then it's gonna say nope after that. So yeah, you have definitely like the ability to build a lot of this. And this is the most versatile thing you have for the entire world. Each car has 32 inventory slots and 2,400 cubic meters of fluid space. They can run at 120 kilometers per hour. They are local or highway, high quantity. They can be used for collectors. They can be used for main lines, worldwide resource highways, and everything due to the filtering versatility and easy expandability of them. Like you can literally do a trains only challenge playthrough, and I bet you could replace everything that has to do with like the longer like belts and stuff like that with this entirely, and only use the belts and pipes to run a little bit in and out specifically to your production lines. I bet you could do that. Now let's go move on to our drones. Drones are really special because they are the smallest inventory. They have 9 inventory slots, and they can manage their speeds up and down a lot based on which fuel, where the trucks and tractors vary up and down depending on how much fuel they use, but their speeds are constant. The speed changes based on which fuel you're using these. So I will put up tables, or I probably have already put up tables for the trucks and tractors, but I will put them up for the drones here as well. And there will be like, these are long distance and low quantity collector lines only. Very simple setup and expansion, and they have only one input and output and then a fuel input, and that means that they are not necessarily going to be able to empty or fill if you're moving them too close to each other. On top of that, the landing and takeoff sequence are over 50 seconds, like constant. That won't ever change no matter how close to them you are. So if I fly from here to here, they are going to take at least 2 minutes to do that trip because the landing and takeoff is that slow. That's why you want to put them like on the other side of the map is their destination kind of thing, because then it takes so much less fuel in terms of fuel per how long it's traveled. Because remember, almost 2 minutes is going to landing and takeoff. And if you have a 2-minute trip, that's all that is. But if you have a 10-minute trip for your drone, then you don't know damn well sure that that trip is only like 8 minutes of actual flight, which is really good because you haven't had to set up autopiloted trucks and tractors, you haven't had to set up trains, you haven't had to set up anything. The drones are really good for that versatility, which is why they're really good to be the vehicle version of the collector, and really good at that. We also have us. We need to move us around the world, and what is a really good way to do that? Hypertubes. You can use these for very quick transfer. When you go in on one end, it will pull you in if they're powered, because they need power. They will pull you along and then spit you out on the other end. Or what you can do is create a cannon, where you go in one, go out almost immediately, go in another entrance, and this will accelerate you for every piece you go into. Say you go up to 100 kilometers per hour, and then this adds 50, so 150, 200, 250, 300, 350, 400 kilometers per hour by the time you're shot out of the cannon. Like that's Formula 1 level speeds going like yeet, and like this is all it takes, and it can throw you across the map. Especially if you combine it with something like the jetpack, or that's the hoverpack, the jetpack, because you can then like extend by just tapping space and keep going forwards for as long as you would like. Really, really good system. Let's move on. The last layer of logistics we're looking at is power transfer. Good power logistics is vital for easy management of your factories. If you mess up with your power management, it can screw over your entire world. And as such, I had a video where I literally did that, and I went around the world and helped fix a player's power network, and most of that was just they hadn't sectioned out their power network properly. So what do we have to pick from here? When you start out, you of course start with the power pole Mark 1 and your normal cable, right? And a power pole Mark 1 can have 4 connections, as you can see there. And then you can upgrade that and get the Mark II that has 7 connections. And then you have the Mark III that can have 10 connections. There's also in the awesome shop versions of this for like wall mounted, ceiling mounted, and like all that kind of stuff. So that you can get varieties of these that are a lot cleaner, that you don't have to place on the ground. And then of course you have your power storage, and once again, like quickly just Google how does a megawatt hour work to see how effective these are. But essentially, if you have a network that runs 100 megawatts, you can run that for 1 hour, or 1 megawatt for 100 hours. So if you want to run something that takes 100,000 megawatts for an hour, you need a 100,000 megawatt hour battery. So that's how, like, very quick and dirty description of that. On top of that, we have our power towers for long distance power transfer. And you have 2 versions of this. The power tower with a platform that has a ladder and everything. I highly recommend mostly, or if not only, using these. And then you'll have these normal power towers. They have 3 of the long distance connections up top, and then they have 4, just like the Mark 1 power line over there, or power node, that you can connect 2 power nodes, normal power nodes. These won't connect up here, they will only connect down here. And the same thing goes for up here, will only connect to up here, like so. And the max distance you can go is 12, just like with the train line, it's going to be 12 and like almost a third in here. But I basically count it as 12 foundations. And these can go for 37 foundations. Technically, I think like it's 36. I think it's like 3 times as long as that one. But like there's a little bit of discrepancy when it like overlaps. And where do you count from? Do you count from the center? Or do you count from the start of that? Or do you count from up here? Like it's up in the air. Now we need to go into talking about some of the like power management stuff and power, like how do you move the power around the world. Okay, so we're gonna talk about the old school meta for power transfer. Train stations and railways. Train station and railways actually moves power. So if you connect up to a power network, which I have over here, and you can see I have power coming in here, no problem. And in here, you can see it's off, and it can drain 101 megawatts. That is the stations, right? But I've also connected up this light over here. You can see that it's off. And these are red, but if I were to do this and turn this on, what will happen now is not only did that one turn green, so did this, and this light is now on. So what happens when you do trains is you get power transfer. The problem with this is you can't connect up your normal like power nodes to the center of this line. The new meta is of course the power towers, but on top of that we have something even more important, which is our priority power switches. And these are a lifesaver for anyone who wants to actually have power logistics working properly in their save. So before we had our normal power switches and we can turn them on and off, right? They like We have two networks, the grid A and grid B. Grid A comes in here, grid B goes out there. No matter which direction you go, they are disconnected by this being off and connected by this being on. And their two different grids will show up here. And you can name them whatever you want. Something that is really important with these though, is they are not communicating with each other or in any other way with you. The priority power switches, however, do. So they have the same setup, the same mechanics and everything. However, what happens here is I can also go into circuit break priority. So it actually checks everything else and which priority it is in. So this one is the example switch, which means it's this one. And I can move that from different priorities. So if I'm getting overloaded power grids, or I'm stop producing power for some reason, like something shuts down, it will shut this off. If it was on, it will shut down that one to save power. If that didn't save enough power, it will move up through the priority groups and keep shutting stuff off until it can run the highest level priority group. Unless that also can't be run, then that also turns off, of course. But then what you can do also from here, like this isn't connected to anything. This isn't connected to like any cable or anything. I can still go in here and turn on and off other remote power switches or other priority power switches. They are a remote control for your entire power network. That's why it is so important to use this, not this. Don't use the power switch, use the priority power switch. And if you follow my doggo meta, you will have the priority power switches very, very early on. You might not even have to start building your first factory before you get the priority power switch. Who knows? Either way, priority power switch, not power switch, at any given time. So this one works really, really well. And as a final little tidbit, we're going to do some troubleshooting to show you guys, new player specific, how to do troubleshooting. And what you do is first you can see, okay, the like bits here are red. And that can be because they don't have any recipe set, or if they don't have any power. In this case, it says no power, so we need to fix that. Over here, I have a priority power switch that is for the tiny factory showcase. And I'm gonna turn this on, boom, and the factory turns on. So what you're gonna see here is that the miner starts going, and it's gonna start buffering in this buffer. And then it's going to split it between these smelters, go into additional buffers after this merger puts it so it's only two lines. Over here, we split one of them into two constructors, and then one constructor over here. This one makes iron rods, this one makes iron plates. Over here, I merged them onto a sushi belt. And then over here, I have a modded block that is a counter that helps showcase how much that is flowing through, to show that, okay, like we're doing this correct or we're not doing this correct. Then I have a smart splitter here that tells you send only iron plates forwards, anything else you overflow to the right. Over here in this one, this is the back of it, you have the left output, iron rods only, and you overflow anything else to the center. This also means that if this gets full, if this backs up all the way out here, it will also overflow the iron plate to the right. Same thing for the iron rods. When these get full, it will overflow center, and then it will just sink all of it in here. That way, we can continue running the factory, plus we get some coupons that we can use in the awesome shop for parts, for upgraded aesthetics, for management blocks, new textures for our foundations, whatever it is. There's a bunch of different stuff you can get in there. But this isn't running properly. And what you do to test or check is you start at your faucet, the mining node in this case. So if I open this, we can see that it mines 120 iron ore per minute. And if we go over here and see this uses 30 per machine, that's 90. So this is mining 30 too much. And in the MAM, in the power slugs section, you can unlock overclocking. But it is a bit of a misnomer because it's just clock speed manipulation, not just overclocking, because you can go lower than 100% as well. So I can tell this to only make 90, and then I can then say that, okay, these are only gonna get what they need. I can look at this. This is a Mark II belt. This is a Mark II belt, so they are fed properly. They can move 120 per minute, so we know that that's enough. That's a Mark I belt, Mark I belt, and Mark I belt, because we know there only goes 30 on each. That's fine because they can move twice that amount. They can move up to 60. Then we look over here, you can see Mark I and Mark I, because they are a 1-to-1 ratio, so we get 30 out on both, and we merge them onto and fill a Mark I belt. It goes in here, and you can see this is building up. This isn't necessarily a good thing, and we want to find out why. The same thing here, it's not building up. That's good, we know that's working. So if we look here, it is backed up, and when you see belts do this, where they stop like this, that is because there is a blockage somewhere or an inefficiency. So then you look at where it's going, and you can see here that it only needs 30 per minute. But if we look over here, we're getting 60. We're getting 30 and 30, so there's 60 on this one. So we can double this. This is where we overclock. And I put in 2 power shards, and I just drag this up to 200% clock speed, and now we are making 40, and we're using 60. However, we can take it one step further. If you have found summer sloops, and you have gotten to the point where you have unlocked production amplification in the alien technology tree in the MAM, you can put in a summer sloop, like so, to double the output again. Which means that where we were before using 30 and producing 20, we are now using 60 and producing 80. This isn't necessarily the most power efficient thing, because a normal constructor uses 4 megawatts, it is now using 40, so the overclock plus the summer sloop put it at 40 megawatts per second. And the overclocking is logarithmic, it's not linear, so if you go lower it will save more energy than it looks like it would, and when you go higher it will use more power than it would by just like multiplying the percentages. So it's not using 8, it's more like it should be using 10, yeah, exactly. So it's actually using 20% more than it should by just doubling the thing. So that's because it's logarithmic. So this is the way we want it now, and if we keep going here, you can see that we're getting some blockage here. Why are we getting blockage here? Okay, that might be because this is a Mark I belt, and this makes 80. We need to upgrade these. So we're making this a Mark II belt. We just pick the belt and we can click it to upgrade. This makes 15, this makes 15, so they only need Mark Is here. But I will need to upgrade along this line. So what happens now is we have a total production here of 110. And that will upgrade over here, but not actually. Because on the other end, we have another Mark I belt that we need to upgrade to a Mark II. And on top of that, we need to upgrade over here. Because remember, these make 80. And then that's split between these 3. So then it's going to be fine. But over here, we will also make sure that we can move the full 110 all the way into the sink. Over here, only 30 will go in at any given time. So that's going to be fine. But the 80 plus 30 needs to be able to move into the sink, and the 80 plus 30 need to be able to move into the storage over here. And then I am moving this into dimensional depot uploaders, and the way that this works is they will just keep building up here until I have the maximum amount. Depending on your upgrades, you can have between 1 and 5 stacks, and the speed goes between 15 per minute and 240 per minute. And you can also get the upgrade where you can take something and put it directly into your dimensional depot uploader from your inventory. That is an upgrade. Really important upgrade for exploration, for map exploration and stuff like that. But yeah, what we've done now is we have added in the upgrades and we have done the troubleshooting. We have found inefficiencies and we have fixed them. So now you can see all the sticks here are green. They are going up in their inefficiency. The longer they run, they're gonna hit 100 after a little bit. You can look over here. You can look over here. Like, they are going to hit 100 once they have recalculated after our adjustments. And that way, you have a working factory. So that's the last thing that I wanted to show in terms of like the troubleshooting and overflow protection and sushi belts and like all this kind of stuff, and how to use the smart splitters, the dimensional depots. Yes, you can move them in parallel and feed all three of them and then triple your upload speed. That does work. It's really, really good for high quantity items that you use a lot of, like concrete. So that is the basics for everything we're looking at here. It's the logistics hierarchy and the logistics layers. And these are all the layers that we can use. Aside from that one, that's just the factory showcase for the troubleshooting stuff. But all of the rest here are stuff that we can use in different combinations to apply in different hierarchies or different parts of the hierarchy. Now, where did I get all of this from? What is my inspiration? What are the roots? We're actually talking about a YouTuber who has a channel called City Planner Plays. And he is an actual city planner. He plays a lot of factory, or not factory, but he plays a lot of city builders and colony management and stuff like that. Like Manor Lord, City Skylines 2, you name it, he plays all of it. And he talked about how you break road networks and road planning into network hierarchies, where you have arteries, collectors, highways, local roads, and all of that kind of stuff. And I basically felt it was a really, really good idea to see how I could apply this, because it made it so much easier to understand how I need to plan the roads and stuff in those games. And I saw no difference logistically to how I need to plan out stuff in Satisfactory. So at the end of all of this, I want you guys to go check out their videos. I'm gonna put a few of their videos in the description, links to them, that where specifically where they talk about like planning road networks and all that kind of stuff. And on top of that, what I do want to do is quickly jump over and just show you guys at the end of this, what will your logistical skills be at? What you're looking at here is the main line for a district, technically a factory, within my mega factory of the city of Mornrock in my Let's Play. And as you can see over here, things are happening, there's junctions happening over here, but generally, if you actually look at this, it's very, very clearly laid out with exactly the hierarchies and the systems that I have talked about in this video. And at the end of things, this will look easy to you. No problem, you can make 10 of these, no problem, it's just a matter of spending the time. And I completely trust that you have watched this video, and if you have any questions or anything like that, that you do put them down in the comments. And yeah, I really, really hope that you will be along for this journey and watch the other videos and learn a bunch of stuff. There we go. We have now finished the first video. I'm really, really happy to have gone through this the second time. I think I did a lot better job of keeping myself from waffling for like an hour about completely, like, not irrelevant stuff, but not stuff that I need to bring up at this point. Now, Bean, do you have anything to say? Okay, well, I have something to say, and I just want to say thank you to all of my Patreons and all of my YouTube members who support me. If you guys want to support me and you really enjoy this kind of content, make sure to go to the Patreon and sign up. You can support from $1 a month, whatever you can do to support, or you feel like you want to do to support. Even if it's just a thumbs up, it's gonna be worth so much. Class dismissed.